For the last few years, interacting with AI has required treating the model like an intern. You have to hand-hold the system through every single step of a process. This produced the discipline of prompt engineering. In practice, this is digital micromanagement, a way to force isolated outputs like a single email draft or a specific code snippet. This one-to-one methodology fails at scale. If you attempt to build a full web application or audit a 500-page legal contract through manual prompts, you hit context limits. Errors begin to compound until the entire project collapses. The human operator has become the bottleneck. Manually managing every instruction prevents us from using AI to execute enterprise-level projects. Anthropic's 2026 models, Claude Sonnet 5 and Fable 5, move the interaction point from the chat interface to the underlying execution layer. This is an agentic workflow. A single goal branches out into multiple autonomous actions that the model coordinates internally. Inputting a goal now triggers a series of interconnected actions across a system, rather than returning a single block of text. Fable 5 occupies the highest level of this system, designed for high-level logic and overarching system design. During internal testing, Fable 5 began identifying critical vulnerabilities in 20-year-old codebases that had gone undetected by human auditors. These security flaws were significant enough that the U.S. government intervened with a temporary export ban to prevent its use as a specialized hacking tool. That analytical depth is supported by a 1 million token context window and native high-resolution vision. It can ingest a 50 million line codebase, as seen in the recent enterprise migrations at Stripe, and maintain coherence across the entire structure. This level of compute is expensive. At $10 per million input tokens and $50 for output, Fable 5 is used for goal-oriented prompting, where it plans the execution of an entire objective. Fable 5 is an architect. It maps out high-level designs and coordinates the execution of complex systems. The labor of that project is handled by Claude Sonnet 5, developed under the project name Fennec. Sonnet 5 costs just $2 per million input tokens, yet it surpasses the 2025 flagship Opus model on the SWE bench coding evaluations. This efficiency allows for a specialized function called Dev Team Mode, using dynamic workflows to scale productivity. When given an objective, Sonnet 5 creates parallel subagents. It assigns one to back-end architecture, another to UI design, and a third to QA testing, all processing simultaneously. These subagents run asynchronously with empty context caches. They don't drag the entire project history into every local calculation, which minimizes the compute cost. Sonnet 5 functions as a fully operational, on-demand workforce running in the background. To test this ecosystem, one developer tasked the models with recreating Terrap 2, a complex 3D racing game originally released in 1996. The user provided a video of the original gameplay and a broad objective to Fable 5. The architect then mapped out the requirements for the physics engine and the game logic. Execution was then passed to Sonnet 5 agents. They simultaneously wrote the code, calculated the 3D physics, and built the user interface. In the final phase, Fable 5 returned as a QA inspector. It identified bugs in the collision physics and forced the Sonnet agents to iterate until the system was stable. In 90 minutes, the models delivered a flawless, playable 3D game. A human never wrote a single line of code. This is goal-oriented orchestration. Users provide the context and the destination, and the models determine the steps required to reach it. Handing high-level autonomy to an AI system creates security concerns for enterprise organizations managing proprietary data. Anthropic uses a security net for these cases. If Fable 5 detects sensitive topics, like cybersecurity vulnerabilities, it automatically routes the request to a secure Opus 4.8 fallback model. This invisible routing ensures the system remains safe and compliant for enterprise use, without sacrificing the speed of execution. Historically, building software was restricted by how fast a human could type. Now, the bottleneck is purely the time it takes for a model to process an instruction. The 2026 Claude ecosystem relies on this symbiotic relationship, Fable 5 designing the architecture and Sonnet 5 executing the labor. The technical barrier to building complex systems has shifted. Today, the only limit to what a single person can build is the scale of their own ambition.